So my name's Ollis. I work at Fastly as a software engineer. We're hiring. I'm also known as Platypus on the internet, and if you're interested in this tech, feel free to contact me on any of these fine websites or IRC. And I'm going to be posting these slides on my website, alienfile.org. I will also put it in the wiki for the conference. So, what is NewRelic? NewRelic is a tool that allows you to instrument your code, and they provide some pretty graphs and alerts from that data that they collect. And then you can optimize and improve your website based on that data. The problem with NewRelic, and you might have already seen this coming, is that they provide bindings for many programming languages like PHP, Java, Ruby, Go, but not Perl. And this is a challenge that I think we have in the community in general, is that a lot of large companies or even small ones, they're just not providing bindings for our desired language. So we kind of have to step up and do it ourselves if we want to use some of these things. So, my first interaction with NewRelic was years ago at DCPM. Brock was interested in this stuff because he was using NewRelic at work where they were using Ruby. And he looked at the list of languages, like I just showed you, and he noticed that one was missing, and he thought it would be interesting to write some Perl code to do this. He called it devel vestige, and he actually contacted them and said, hey, do you mind if I work on this stuff? And they said, sure, go ahead, we don't mind. Please don't use our trademark, and that's why he called it something other than NewRelic. Otherwise, there wasn't really any assistance, and like I say, he was doing Ruby at work, and it wasn't paying the bills. So the project didn't really reach a useful state, but it was an interesting idea. So a few years later, I'm working at Fastly, and they're already using this thing called NewRelic Agent, which is a Perl module that bundles something called the Agent SDK, which was a library that NewRelic provided to instrument your code. And it was written in, well, I don't know what it was written in, but you could call it from C. So this module used XS and C++ to call into that library, so you could instrument your Perl program just like all those other languages. Now, the problem was with this library is that it linked against the library in the install directory. So as soon as the install directory goes away, your cpan M cache, this thing stops working. So that's kind of a problem. The other problem is that it was a alpha product. It was never really officially supported. It also came as a binary blob. So if you wanted to fix something, or you found a bug, or you wanted to improve something, you're kind of out of luck there. It's only 64-bit Linux, and it also linked against an old version of the Ubuntu OpenSSL. So I'm pretty sure there was some security issues there as well. So my first kind of like incremental improvement on this was to write some FFI bindings instead. So the first thing I did was I fixed the install library thing that was going on. So as soon as the install directory goes away, this thing still works. And I did that using Alien technology, which we're going to discuss in a bit, instead of bundling the Agent SDK with the module. Arguably good, we got rid of the XS and the C++ code, but unfortunately everything else that was wrong with the previous module was wrong with this one as well, because it was fundamentally bindings for the same library. Now, a few years after that, NewRelic introduced something they called the C SDK. That's a C library that is designed to instrument your C application for NewRelic to use for C applications. Now, if you kind of squint, Perl is in fact you don't even squint that hard. Perl is kind of a C application itself, so we should be able to call this from Perl as well. The nice thing about the C SDK versus the old agent SDK is that it is open source. So if you see something that you want to improve, or if you find a bug, you can actually pretty easily go ahead and do that. It was officially supported on Linux, and mostly portable to other platforms. So if you don't mind a little bit of work, you can get this to work on Mac OS. So the way I wrote my bindings is I created an alien for the NewRelic CSDK. This downloads, patches, and installs the CSDK into a private share directory, making it available to other Perl modules. Yep, did that one already. And then from that, I was able to build on that using what I called NewFangled. And I called it NewFangled instead of NewRelic. NewFangled is, comprehensive Perl bindings for the NewRelic C SDK. And I left NewRelic available to NewRelic. So NewRelic, if you're listening, it's good. You can do it yourself. So just a quick review of what Alien is for those who haven't had experience. Alien is a namespace that is reserved for non-Perl libraries and tools to make them available for other CPAN modules. The Alien should use the system library if it's available, and if not, it'll download and build it from the internet or bundled and install it into a shared directory so that it's available to other CPAN modules. It doesn't install it into the system area, so it won't mess up existing system libraries or anything like that, or packaging systems. Oops, went one too far. And this is just a diagram of the way the Alien flow. You install the module, it says, is this library existing? If not, build, test, install. Either way, it records the compiler linker flags. And the final step in installation is it will test the Alien to make sure that it works by building a toy XS or FFI module and make sure it works, and then we're done, we've installed it. This is the Alien build architecture. So Alien build is you don't have to use Alien build. It's, you can write your Alien, manually. The Alien build infrastructure sort of provides some tools to make it easier. It covers a lot of corner cases, especially if you want to do support Windows and stuff like that. So on the install side, you have your makefile.pl that uses makemaker and Alien build mm. Alien build mm is just a thin layer between makemaker and the main Alien build infrastructure. And its reason for existing is basically so that we can, swap it out and use other installers if we decide to in the future. So there's Alien build MB as well for module build. Now, Alien build uses a file called Alien file, which is just essentially the recipe for how to find the library and or build it. And then at runtime, we have the Alien module itself, which is usually just an empty subclass of Alien build, Alien base. And Alien and the infrastructure knows whether it's a share or a system install, and will provide the appropriate compiler and linker flags. Now, the reason I painted some of these things orange is because those are the only things that you actually have to write if you want to create one of these things. And actually, in the case of the runtime, usually you're just, like I say, building, it's just an empty subclass. And so normally you don't even have to write that part. Okay, so what does this Alien file thing look like? This is an Alien file for an AutoConf project named libarchive. And it's pretty simple. It uses plugins that are available from Alien Base, Alien Build. So you don't really need to do anything too complicated here. And if the thing that you're alienizing is either autoconf or CMake, this is essentially all you have to do, and it should just work. So the CSDK was a little special though. So it uses, it's like kind of vanilla make, and we had to kind of do some manual work. So yeah, the build step, instead of using plugins, is just a series of commands. So we say we build the thing, and then we copy it into the appropriate directory so that it can be used. And the other nice thing about the Alien file sort of structure is there's a patch phase. So you can actually patch the source code between when it gets downloaded and extracted and when you build it. So in the case of the CSDK, it was actually really useful that the CSDK was on GitHub, because they actually had a number of PRs that were already open against it that were useful and that I wanted to use. The first one was the CSDK provides a mechanism for transmitting stack traces to NewRelic. The problem is it was designed just to work with C. So it looks at the C stack trace and sends that, which is not very useful when you're debugging a Perl application. So somebody had written a patch to transmit a sort of an arbitrary stack trace to NewRelic, and so we apply that, and now we can send our Perl stack trace instead. That's annoying. I should have closed Slack. So the second patch was for host names. So we run our application in Docker, and so every time the Docker container, we have a new version of the application running, not version, instance of the application, it's a different host name. And that's very not useful when you're in the portal and like the host names are always changing. So we added a method to set the host name manually, and yeah. The other two patches were just like, compiler warnings or errors that, supported additional compilers or platforms. The other thing that was really useful was somebody had provided a patch to get this to work on Mac OS. And even though we use Linux in production in Docker containers, most of our developers are have Mac workstations. So yeah. And nice thing about the Alien, since Alien file is just a Perl source script, basically you can add logic. So we only apply the patch if it's Mac OS, and then we also have to keep track of the extension on the dynamic library. And this is the runtime module, and as I mentioned, it's a completely empty subclass. Alien Base can determine the appropriate location and flags from the name of the class. So this is all you have to do. So the next technology that I used in this project was FFI. What's FFI? Foreign Function Interface, or FFI, is a method by which code written in one programming language can call code written in another. By this definition, XS is actually an FFI. But frequently, FFI is used to refer to this technique where a compiled language like C is called from a dynamic scripting language like Perl. And that's generally how I will use the term. A platypus is a semi-aquatic egg-laying mammal which frequents lakes and streams in eastern Australia. I once saw a platypus near the Jenolan Caves in Australia on one of my many visits, and it was just really magical to see it in the wild. I'd often seen them in zoos and stuff like that, but it was really special to me. Platypus is also a library for writing bindings in Perl using this FFI technique. I so named it because, platypuses are cute, and also I'm originally from Australia, so I like to represent. Also, just the idea of gluing a duckbill on this mammal and this weird tail, and they're apparently poisonous as well. So it just seemed kind of appropriate for what the tool is for. So just to compare this with XS, this is what the install and runtime looks like in XS. XS is sort of the instructions for how you communicate with the C world from Perl. And it gets compiled into a C file, linked with other C files potentially, and possibly system libraries. And you build this sort of intermediary dynamic library that you can then call from Perl at runtime using DynaLoader. I think there's one other, there's XS Loader as well, so you can use that one as well. So FFI, on the other hand, is a much simpler proposition. So at install time, it would be nice if you check to see if the library exists and bail out. But technically, all you really need to do is nothing, because your tests will fail if the library is not available. And then at runtime, you can just call into this library. It's a much simpler diagram. So when I was writing the NewFangled bindings, I wanted to make sure that the library exists. And if it doesn't, fall back on the alien. That way, we're sort of limiting the extent of dependencies that you need. And nicely, you can do this in XS actually, but it's a little bit more complicated because you need to know, because of the timing of when you know what you need and what you have. But in FFI, you can basically just check for the library and say, oh, I'm going to need this at runtime, so add this as a prerequisite. And I'm using Dacilla, and there's a nice plugin for Dacilla that allows you to do this pretty easy. We just there's a library called FFI checklib that I also wrote, which will find the library. And if it doesn't exist, we add the prerequisite. And then at runtime, we use FFI checklib to find the library. And we say, this is the library that we want. We want libnewrelic. And the alien option tells it, okay, if you can't find it in the normal system locations, then try the alien. And that should only be necessary if it's not already installed. The only time you might run into trouble is if it's been uninstalled since this module is installed. So now that we've found the library and we're going to use it, let's talk about types. So simple types like integers, floats, and strings are very simple to write bindings for in Perl using Platypus. We use the attach method to basically create a binding for individual functions. The first argument is the name of the method. The second is the argument types that you pass in, and finally the return type. So these are very simple functions to bind. Now, I mentioned before that we added a patch to allow setting the host name, but if you're using a version of the CSDK that was built by somebody else, it might not be available. So we go ahead and check to see if that symbol exists, and if it does, we attach the method, and otherwise we kind of implement a failure mode where if you try and call this function, it returns a false value. The other way you can handle, this is not the way I did it, but the other way you can handle non-existent methods, which comes up from time to time, is by telling Platypus just to ignore it. So if you say, if you set the ignore not found attribute to 1, then if the function exists, it will bind it, and if not, it won't. And this is, the downside of this obviously is that if your caller wants to use your code reliably, it has to check to see if those methods exist or not. But for libraries with lots of functions where you're not sure exactly what subset are going to be available, usually there's a lot, but there's usually 1 or 2 that are not, this can be a useful mechanism for handling that. So we got simple types, and now we're going to talk about structured data. So structured data allows you to combine named data of potentially different types. And in C, this is how we kind of represent this kind of thing. Just as an example, I'm using a color structure which has red, green, and blue values of integer type. And in Perl, of course, there's more than one way to do it. And depending on what you're trying to do, you want to use different methods. And these are the kind of 5 that I'm going to focus on right here. FFI Platypus record and FFI C sort of provide direct access to structured data. So when you need to actually manipulate the individual members of a structure before passing it into C or vice versa. The other 3 types, opaque, object, and pointer object, are for when you're not really supposed to understand or access directly the underlying structured data, and your library is supposed to provide a useful abstraction instead. So let's talk about passing structures by value. Here we have the same structure that I talked about before, and we got a function f that takes a color t. And when that gets passed from the callee to the caller, the entire structure gets passed into the callee. And so it can read from those values and write to them, but it won't affect the version that the caller has. This is, my experience, this is pretty unusual in C. So you don't need to use this kind of calling structure much when you're calling C code, but languages like Go and Rust often use this kind of thing, especially for the way they store strings. So, and now this is how we implement this in Perl. We use FFI Platypus record. You just create a color class. You indicate the structure for that class. We have our red, green, and blue values of integer type. We create a type alias. We say that that class is associated with a color underscore T FFI type. And now we can just attach the F function like we did before, only we can create this structured data and pass it into C. Done? Okay. Whew. We need, I'm obviously too sober. So next step, we want to pass by, this is what the memory layout of that pass by value kind of thing looks like. So the FFI Platypus record is a reference value to a string, basically, and the string is the binary data of the structure, and it's got methods to access the slices of data that it needs for each member. And we just copy that into C, and C can use it, and it can think that it's coming from C or somewhere else. Well, Perl is C, so it is coming from C. So, but often we want to be able to, the C code to modify these values and see them in Perl. So what we want to do is pass by reference, and in C, you just add, well, or pointer, I guess more technically. So in C, we just add a star to the argument, and it becomes a pointer. And now instead of passing the full structure, we just pass a pointer, this address, into the callee space. And in Perl, we can still use the Platypus record class to do this. We just add, just like C, we add the star, and this works exactly the same. But better, I think, is to use FFIC. This is a library that I wrote to be a little bit more sophisticated with structured data. Again, you create a color class, and you have the layout defined, red, green, and blue values of integer type. We attach the function, and this time actually we don't have to tell it, we don't have to explicitly create the type alias. That's because FFIC is smart enough to say, oh, color, the color class, you're probably going to want to refer to that in C as color underscore T. And if you, and sometimes maybe you don't want to do that, and there is a way to override that, but the default is kind of sensible. But if you look at, so the last two lines are kind of how like a user would use this function. And if you'll notice, this one is identical to the last two, and that's kind of a tenet of designing good stuff, is that the person who's using your FFI binding shouldn't need to worry too much about how it's actually implemented. So this is how the pass by reference looks in memory using FFIC. It's a little bit different. So in this case, color is a blessed reference to the color class. And the reference is to an integer value, which is the pointer. That pointer points to the region of memory that Perl and C are sharing in order to pass this data. And sometimes I get asked, like, when do you use record and when do you use FFIC? So it's a good question. Basically, use Platypus record anytime you want to pass by value. And use FFIC anytime you need unions, nested structures, or arrays of unions, or arrays of structures, or arrays of nested. Basically, use FFIC anytime that you're not passing by value, because that's the one feature that it doesn't have. Did I say that right? You don't want to use it when you're passing by value. And this is the reason why I wrote FFIC, actually. I wrote it when I was working on these NewRelic, NewFangled bindings. This is the the root level of the NewRelic C SDK configuration object. It has a number of string members, but then it has these structures inside of it, so it's nested. And so I can refer to those substructures using the types that have already been defined. So all these declarations are to basically define the one configuration object. And because Platypus record is actually a Perl scalar value, that's the way it's stored, there's no way to nest those things or create arrays of those things. There are some other structured data options I just want to mention real quick, may be useful in certain cases. Pack and unpack is part of the Perl core. It's super fast. So if speed is the only thing, this is probably the way you want to go. It's also a little esoteric and maybe not for some applications all that maintainable because it's very sort of difficult to read. There's also a module called convert binary C, which I think is pretty cool. You feed it some C header code, and it'll allow you to convert between Perl and C data structures really easily. It's pretty cool, actually. Okay, so the other kind of form of passing data back and forwards I wanted to mention, as I mentioned before, was opaque data. So when the library you're calling is managing the structured data, and you just sort of are passing a handle back and forward, this is sort of a good pattern to use, because that way the implementation and the storage and the layout, all that stuff can change without you having to recompile your code. It's just a good abstraction. And the best C libraries that are available from available to other languages use this kind of interface. So NewRelic, for some of their objects, use this kind of thing. The config one was the only one that had this grid structure thing. You've got an app object and a transaction object, and these are defined in the header file, but they are just defined as structs. They don't just define the actual structure inside of them. And so from C, we create the NewRelic app object. From that, we can create the transaction. Then you write a bunch of code that you're trying to measure, and then you end the transaction, and then you can destroy the app handle. You're not destroying the app. So there's a couple ways you can handle this in Perl using Platypus. We can use a raw opaque type. An opaque is just a pointer stored in a scalar integer value. And this is kind of how that code would work. So the first line here, Mangler tells us that we're going to use NewRelic underscore as a prefix for all these methods, so we don't have to repeat that over and over again. Then we say create app. It takes an opaque, it returns some values, etc. Start web transaction, end transaction, destroy app. And this is the Perl code that calls that code. And this will work, but there's a couple of challenges here. You've got these raw pointers, and you have to kind of remember to end the transaction and destroy the app handle. And if you have a complicated code base, that can be quite a challenge. This is what the memory layout of this raw opaque type is. The app is an integer value, which is just a pointer into the memory region. And this is conceptually, this is technically exactly like the pass by pointer, pass by reference that I diagrammed before. But now the actual structure of the NewRelic app object is entirely in the NewRelic side, because we don't, from the outside, know anything about the structure of that. I think in this case, a better thing to use would be the object type. In Platypus, object type is a blessed reference to a pointer stored in integer value format. And this makes it easy to write binding codes for object-oriented code like this. And it's also safer because it does type checking. So this is the sort of incantation that you get to associate a class with a particular type. We say we want NewFangled app to be associated with the new app underscore t, and same with the transaction. And now we can just use those types in creating our bindings, and Platypus will automatically, when it comes into Perl space, it'll bless it, and when it goes into C space, it'll check that it's the right type and pass the pointer. The destroy method was a little bit challenging. It's a bit, so they do this thing in the C SDK where when you destroy an object, you pass in not the pointer, but the pointer to the pointer, so that it can assign that pointer to null. So the next time that you accidentally pass that into another function, it'll know that you've already freed it and not try and use it. So it's really useful if you're writing a C application because you won't crash, but it's kind of annoying when you're writing FFI bindings because it's kind of unnecessary. So this just has a wrapper that basically creates a pointer to a pointer and passes that in instead. So now we can use the object, we can create the app instance or handle, start the transaction, we can write the code that we want to measure, and then we can end the transaction. We don't have to explicitly destroy the app handle because that's done in the destructor. And the transaction actually also works the same way. If the transaction falls out of scope, it will end the transaction as well. So if you do, for some reason, forget to do that, you don't have to worry. And this is what it looks like in memory. So the app now is a reference. It's still a reference value, this time to NewRelic app, but it's referencing an integer value, which is the pointer to the region of memory where the internal structure that NewRelic understands is. Pointer object is similar, but it's stored differently. So it's a blessed hash reference that includes an opaque pointer value called PTR. This allows attaching additional Perl data to your opaque object. Yeah, that's all I wanted to say on that. So the incantation is a little bit dense, but basically this is a similar thing to what we were doing before. It associates NewFangled segment in this case with NewRelic segment T, and there's some translation that's done to go from one to the other. So now we can actually create bindings for this segment object. We create the segment off the transaction. So a transaction can be divided into multiple segments so you can see what part of an entire transaction is taking the most time. And the segment needs to know the transaction to which it belongs. So that's why I used a pointer object here, where we, so for each of the methods on transaction that creates a segment, we have this wrapper that says create the object and then add the transaction as well. And then we have the segment class where we attach some more functions. These are, what they do is not really that important. The idea that you can just add methods is kind of useful. And then a transaction accessor method, so you can get the transaction object from the segment. And the end segment, or destroy, and this will look familiar, but now we have to, so the end segment method in C is actually, you pass in the transaction as the first argument, and the segment, a pointer to the segment as the second argument, which is, it seemed backwards to me, but that's the way we do it. So I needed a wrapper to do that. And then destroy calls end if the segment hasn't already been ended. And this is what it looks like in memory. Your seg variable is a reference value blessed as NewRelic. Sorry, it says NewRelic, but that should be NewFangled segment. And it references a hash value which has pointer and transaction members. And like, it should be obvious, but you can add arbitrarily complicated additional members to your object if you need to. Again, we just copy the pointer to C. C doesn't need to be aware of all the extra stuff like the transaction, and it can do its thing. So, NewFangled works. I will use it in production. I've actually shaved about, one example, we've actually used this for a number of things, but I've actually shaved about 15 seconds off of our global deployment time, which is, it's not, I'm not supposed to say how long it takes, but that is for, you know, that is significant. Everything's awesome, right? This is great. This is excellent. It's awesome. Oh, NewRelic has decided to discontinue the CSDK. So, yeah. They suggest using OpenTelemetry. So I think actually on balance, this is actually a good thing. There exist a number of OpenTelemetry modules on CPAN already, and I think you know, being able to do this in Perl, pure Perl, I think is ultimately probably better than having to rely on an external library, especially one that's kind of a bit weird. So I've jumped through a few hoops. I'm probably going to jump through some more to support this eventually, but I'm not mad. And actually, I've improved the state of FFI quite a bit in this project. Like FFI-C didn't exist before. Actually, I think pointer object is new too. I can't remember if I specifically wrote that for this project. But it was very close to it anyway. So I was kind of working on this stuff anyway. So, and so even if the CSDK does go away, and as I understand it, it's not going to stop working. But even if it does go away for us, I think that we've built some useful tools using it. So. Again, these are the links to, you know, if you have questions or comments or just want to say hello. And yeah, that's all I wanted to share today. Does anybody have any questions?
So what's with the reference to a scalar for a C object? That seems a little excessive versus having a scalar in each C object.
Well, with Well, because you can bless the reference into a particular class, so that the pointer is associated with a particular class. Yeah. I mean, if you don't need to do that, if like, pure speed is the only thing that you care about, you can use the opaque type. That's what it's intended for. But often you have, my original libarchive bindings actually did that. And it was a mess because you had to keep track of, the handles and everything like that. And having it associated with a class and being able to add a destroyer to automatically clean things up, just, there's a cost to that, obviously, but the benefit was my sanity. Anybody?
Your Alien or FFI stuff allow using, let's say, library-provided memory allocator for nested structs. Or no, there's some C libraries have their own malloc tools, or you have to create a multi-layer C struct using their allocator to automatically create you at the end.
Yeah, so FFIC, if you create the FFI, the object, it will use malloc to do that. But if the object comes from C space, it will not use the, it'll use it's already allocated. So C space will worry about that. And that actually works pretty nicely because that works nicely because usually when it's allocated in C space, you're not supposed to deallocate it. So if you're getting sort of a pointer from C space, you don't want to also delete that memory. And there are some tools to take ownership of the pointer, and you can manually free it if you need to. But that is normally that's kind of the ownership model that makes the most sense. And C doesn't always honor those. C libraries don't always honor those sort of those memory models, but that's the default.
So I don't understand counting on exit for random reload.
FFIC, no, it frees the memory when the object falls out of scope. It will if it's created inside Perl. If it comes from C, it won't. So you do have to be a little bit careful. If you do need to do like an explicit free, there are ways to do that. Yeah, but it's by default it doesn't do it implicitly. I mean, there are ways in C to do that, but yeah, that's kind of beyond the scope. Yeah. Anybody else have any questions, comments, thoughts? I mean, the same security things that you run into with XS. You're fundamentally calling a subroutine. You're passing in values. If you're not being careful, you certainly can shoot yourself in the foot. Yeah.
Pack does have, I believe, arbitrary memory capability. Self-creating that memory at the process. Check at syntax. Yes, you can read anybody anywhere in the process. Core Perl tool. There's no safety. Perl and
Did you have a question? I'm sorry, what? Oh, yeah. Yes, so that's a good question. So does the source for Alien have to be the internet, basically, arbitrary URL? No, you can actually also bundle code with your Alien. I sort of tend to discourage that because I feel, if you're alienizing something and you're bundling it, then it's a lot of reproduction, and it actually makes it harder for distribution maintainers, Debian and stuff like that. That's like an extra thing that they have to worry about. Yep. Yes. So there are a couple ways to handle that. There is a way to force Alien not to ever go to the internet and fetch stuff. There's an environment variable. You can tell it to force a system install. There's also a plugin that will actually allow you to modify the URL locally. So you can say, oh, sorry, for this URL, actually go to here. And so that allows you to handle that. Ideally, I think what you want to do is use the system library if possible, but we do try to make it as easy as possible. Well, yeah. Right. So what if the system library is too old? Well, the Alien file should specify like a minimum required version. Yeah. Yep. So it depends on, unfortunately, there's no real standard for this. Package config is kind of the most common one. So there's a lot of code in there for that, but yeah. Anybody else? Well, thank you very much for coming to my talk. I appreciate it. And again, I think the slides should already be up. And if you're interested in this tech, we have lots of forums and stuff like that to ask questions and make pull requests and improve things and you name it. Thank you.